All right, let's see. Welcome, everyone. See, we have Dhruvam, Jacob, Aditya. Welcome. Hope everybody had a great summer. Ready to go. Can everybody hear me?
Yes, Professor, we can hear
Hey,
you.
hi, Professor.
Awesome.
Hello, everyone.
Awesome. Very good.
Hi, Professor. Hello, everyone.
All right, let's give everybody a couple more minutes. Is everybody still back home, or everybody's still back on campus?
Back home.
On campus.
On campus.
On campus in Boston?
Yep.
Yes.
It's great. Hopefully we'll have some semblance of normalcy slowly opening up for everybody. Let me see if make sure that I can share. All right, can everybody see my screen?
Yes, Professor, we can see.
All right, let me move the chat over here. Move this over here too. Okay. It's over here. Okay, excellent. Okay. All right, another 3 more minutes. Can I see who on the call is from CS 4500? Can I see a show of hands? Okay, Kathy's 4500, Jacob, Andrew, Alejandro. How about a show of hands, folks from 5610? So Monil, Priyal, Harsh, Yimeng. Okay, awesome. I just wanted to make sure that both folks were able to come in the call. Right, just a couple more minutes. Okay, I got some folks in Seattle. Anybody from back home, maybe in Europe or Asia? Well, it must be really late over there, no? Harsh, Ting Ting. What time is it over there, Ting Ting?
It's 4 o'clock in the afternoon.
Oh, okay, not bad.
Yes.
How about Harsh? What time is it over there?
I'm currently in Boston.
Oh, you're in Boston? Oh, okay, you
Yeah.
had your hand raised. Anybody in India? No one in India? Everybody's here? All right, it's 7 o'clock. Let's get the show on the road. Welcome everybody. My name is Jose Anunciato. I'll be your instructor for web development. We do have two sections going on together, CS 4500 and CS 5610. It's the material is quite the same, but the amount of work is different for both sections. We will be having much more considerable work for the folks in the CS 5610. I know that the CS 4500, 4550, the undergrads in general have a much higher workload with many other courses going on at the same time. And the graduate folks perhaps also have some more experience. Maybe they've been on an industry and perhaps had been more exposure to some of this material. So we could ask a little more of them. But in general, the technology that we're going to be covering, the topics, it's basically the same. Yeah, so we did do a polling on when this lecture might be more convenient for folks, and looks like there were it was between either having a one single night, a 3-hour night on Wednesdays, or having two, one on Tuesday, one on Thursday, which was the original schedule. And they were right there and then, but I think the one on Tuesday and Thursdays won out. Also, if we had done just one night, it clashed with another class that also was that same night, so they would have lost the entire material. So at least folks are going to be able to see at least half of it. All this material will be are recorded, and but you should consider the recording as a convenience, as a for you to go back and review, or if you must miss the lecture, so definitely that's a resource for you. But the intention is the expectation is that you will be here live. If you there is time sensitive information and assignments and whatnot that definitely you need to be on top of it. You might have heard this course is very hands-on. It moves very quickly. There's an assignment every week, and so the semester goes by very quickly. So you really need to be on top of it. All right, so we are here for web development, and what we mean by development and web, right, is that you apply the same type of techniques that you would apply developing any piece of software. We just happen to be using the web as a means of interaction, of delivery, and all the things that the web opens up, right? The access to all sorts of data sources that you can retrieve data dynamically, and distribute all the work across multiple servers, and design it not for individual users running on a particular desktop, but instead developing for applications that are interacting with potentially thousands of users accessing it simultaneously. So there's quite a bit of techniques of how is it that you design applications that are not desktop, right, are not for one single person, but how is it that you deal with thousands, hundreds of thousands of folks simultaneously. So there's all these techniques that you need to take into account. Let's see, participant requests that live transcripts be enabled. Of course, enable. If you do have a question, try to either raise your hand or also make the question on the chat. I'll be looking once in a while to see if there's anything on the chat, and I'll repeat the question for everybody, and then I'll answer for everyone. Okay. So and feel free to interrupt me, and then I'll get to the questions as I go. All right. So let's take a look at the syllabus. All right. So first of all, we are using Canvas as our main software for delivering the course material, and you should all be able to log in there and navigate to the home page. That's the default place in the canvas that you dropped in, and this is the same for either CS4500 or CS5610. The layout should be identical. And then there's a link to the syllabus and the modules. Modules are breaking up all the content. Some of the content is throughout the semester. You have access to the syllabus, the piazza, the link for the lecture and whatnot, right? You also have access to links to the office hours that we're going to be running throughout the semester. So it's all there. But then there's also some material that is time sensitive, such as week 1, week 2, week 3, and so on and so forth. So all this material will be made available in time. So today, it's kind of like a half a week. So it's kind of a weird week, right? So the material that we're going to be covering today is just for half a week, right? Also, the assignment is also meant to be that you should be able to complete it in that half week as opposed to taking the entire week. So that's week 1, and then week 2, we'll be introducing more technology, HTML, CSS, JavaScript, and whatnot as we progress, right? But for that, let's get back to the syllabus that goes over that material. Okay, let's see. All right, so this is the syllabus. And so the goal of the course is to learn to develop applications, right? Using the web as the means of delivering these applications, right? So we're going to be using the same types of techniques that any software engineering project would need, right? So obviously the same concepts of object orientation and component technology and all the best practices, different design patterns that apply for any software engineering project also apply here. We just happen to be using a different set of technology stack that enables us to take advantage of the fact that we are running using a particular architecture, the client server architecture, that we're running on a server that has access to the network and whatnot, right? And we're using a specific set of technologies that allows us to dynamically generate content, dynamic HTML and whatnot, right? So it's applications, but running on the web, and all that entails, all the limitations and opportunities that entails, right? So lectures, the expectation is that you will be attending these lectures live. I know that on Tuesdays, this lecture does conflict with some other folks. So I would expect that maybe Tuesdays will be less attended. I imagine so. That's fine. We will be recording this live, and you should be able to view the material shortly after. On Thursdays, I believe that folks didn't have that many conflicts, so hopefully Thursdays everyone will be here. So the assignments is the backbones of the course, right? The assignments are designed to propose a problem and then use what we've learned in class to solve that problem, right? And we're going to be building an application all throughout the semester. It'll be the same one application, and everybody's going to be building the same thing in the assignments, right? And it's going to take us about 8 or 9 assignments to complete the project that we're building. Everybody's doing the same thing. And every week we're going to introduce a new technology, and the assignment is designed to apply that technology, right? So you get an opportunity to practice that technology as you build this application, okay, an end-to-end application. But at the end of the semester, towards the last 2-3 weeks, you will be tasked to build a project on your own. Well, not on your own, as a team, right? Throughout the semester, you should be meeting folks or folks that you already know, and form teams that are meant to collaborate, right, and build something of your own choosing, right? You'll choose whatever the project is that you want to work on. There's some general ideas or general concepts and requirements that all projects need to meet, and but they're pretty broad, right? So they are broad enough that I believe that most of anything you could possibly think should fit into these project requirements. Hopefully, about 80–90% of whatever you might think should be covered with the general requirements. Obviously, there will be some projects that might want to go a little further, or it's so novel, so new, so crazy that it falls outside the specifications of the project, and that's fine. We want to work with you. Please let us know if you see that what you want to build really is out of the box of what the box that we built for you. We want to negotiate with you and let you really allow you to really express yourself on something new. The teams would be teams about between 2 and 4 students is what I'm thinking. Although if you want to work on your own, that's totally fine. I think for one person, the amount of work that we're expecting from you for the project is a little bit too much. But if you feel that you can handle it, that's totally fine. If you want to go at it alone, that's fine. If 4, I think, is the maximum. I think even 4 is a little bit too big. And I've run these projects for quite a while, and it always turns out that bigger teams always have problems, right? Of collaboration, that some folks worked more than others, and at the end of the semester, everybody's pointing fingers or saying, oh well, no, he didn't work and I worked and blah blah blah, and I'm worried about my grade because. And so I would suggest you avoid large groups, of 4-member teams, unless you folks know how to work together well and divvy up, and you can guarantee that there's not going to be any drama at the end of the semester. But nevertheless, I do want to give you the opportunity. If you want to work in bigger groups, that's fine. We are going to be using Zoom like we are today, and the link is over here just for convenience, but obviously it should be available also at the on Canvas. We are meeting Tuesdays and Thursdays like we originally said. We are meeting for an hour and a half. The lecture 7 to 8:30, and then office hours will be right after class, right? So if you want to stick around after the lecture, we can, if you have any questions or if you need help with assignments or any general questions, then just stay on. The link for the office hours is just the same link for this Zoom meeting, right? So even if you don't come to the lecture and you just want to come to the office hours, it's the same link, right? And I'll just stay on after after we complete the lecture if anybody come by. The team, let's see. So that's this is me, and also and this is the team for dedicated to CS 4550 and the team dedicated for 5610. Right. So we have many more folks in the CS 5610 course. So we do have some more folks there as well. The TAs are putting here also the time that they will be holding office hours. They should be holding twice 2 hours twice a week, right? And we're trying to spread it out throughout the week so that you'll have plenty of opportunities to get help, right? So the team is of a total eight TAs, and any TA can help anybody either from 5610 or 4550. So don't feel that you only can go to the TAs for your particular section, right? Any one of them can help anybody.
Dr. Annunziato,
yes.
Just a quick question about TAs. What are the kind of questions that the TAs are going to be best prepared to answer? And then what are the kind of questions that you are the best person to talk to about?
So the TA technically, anything that's technical, the TA should be able to answer. Whether you lose a particular point, that there's a dispute on whether you should get credit for certain things, and that it was not well defined perhaps in the assignment, and there was some interpretation, and you lost points, blah blah blah, they might refer you to me and say, well, I took points off, but if you really want to then talk to the professor, blah blah blah. Also, if there's any if anybody loses their temper or there's some drama or anything like that, first come to me. I'll be the best person to talk to if there's there's anything that has nothing to do with academics or anything like that. In Piazza, you can send private messages. Let's please try to stick to Piazza. We're going to be using Piazza as our main way of communicating. There's no need to send me a personal email. You can send Piazza messages, private Piazza messages to me or any one of the TAs. So it'll make it easier for all of us to have just one place where all the messages happen and whatnot, right? Because if you start sending me emails here or text messages over there, I might miss something. If I have one single place to look at, it'll be faster for us to help you. All right. Will this be similar to a full stack project? Yes. The assignment will be a full stack project, right? So we're going to be using HTML, CSS, or JavaScript, React, Redux, Node.js, Mongo. So the full stack for the assignment, and the intention is that you will feel confident enough, right, to then go on and do it yourself, right? The course is designed in such a way that you watch me do it, right? You watch me do something, and then in the assignment, we handhold you through the same concepts that we covered in class, right? And so we try to handhold you, and you practice what you just saw me do. Now you do it on your own. What you just watched me do, and then after several weeks of practicing this, ideally, at the end of the semester, you would have enough. You would feel confident enough to tackle an entire project on your own. Well, not on your own, but between 2, 3, or 4 folks amongst yourself, breaking it up and working together. Right. That's the intent, right? That's how the course is designed. Watch me. Now you try it, and then go ahead and do it on your own. Okay. And then I watch you do it. Yeah, I think those are the 3 steps. You watch me do it. Then you practice it, and then I watch you do it, right, on your own. Okay. All right. So here's the agenda that we're going to try and stick to. Let's see. So yeah. So we are going to be together for about 14 weeks, and of which this week is kind of like a half week. And today we're just going to introduce the course, about grading and whatnot, and then we'll jump onto the first assignment, right? A1, right? Assignment number 1, and it's going to be due next week. Okay. And the intent of this particular assignment is to get you going with the development environment that you're going to be needing, right? We're going to need a particular IDE, and we'll have to download a couple of tools, Node.js. We'll create a simple React.js application. We'll deploy it. We'll push the source code into source control in GitHub, and then deploy it into a remote server, right? And it'll be the trivial default React.js application, and we just want to show you the entire process, right, of going from nothing to having something deployed remotely. So we'll do that today, and then we'll ask the assignment number 1 asks you to go on and do it on your own, and that development environment is where we're going to be doing most of our work throughout the semester, right? Next week we'll get started on introduce you to HTML as the main language for formatting and providing content for our web applications. Let's see, full stack. Will this course dabble into AWS? So you certainly can use AWS instead of, we're not going to use AWS. I used to use AWS a while back, and it was such a pain to, folks were having always so much problem on installing it and deploying it and whatnot. If and I ended up, debugging 300 AWS deployments, right? And it was just, I was just going nuts. Instead, we're going to be using Netlify. It's just a push button and boom, it's deployed. Okay. But you certainly can use AWS, and we will support you. Ideally, it'll be a minority of folks who decide to go the AWS route. We'll fully support you if if you run into an issue, but then it won't be 300 folks having different problems deploying AWS, right? So definitely, if you want to dabble in that, we will support you. It will time to be due before the start of the class. Yeah, no, the due dates are always going to be at midnight. So whatever day that is, the midnight of that date. Okay. Yeah. So let's see. The assignment due time is no, due date should be at midnight. Yeah, not 9 o'clock, 9 p.m. at midnight. Let's see. Yeah, so HTML, we'll start HTML maybe today, or perhaps early next week. Yeah, so then we'll tackle CSS as another language that allows us to style the content, right? Telling things what font to use, what colors, what background, what images, and whatnot. And we'll spend a week talking about CSS. We'll then, after learning how to use, how to do the multiplication table, we'll then somewhat abandon it a little bit and introduce Java CSS libraries such as Bootstrap and Font Awesome that are going to allow us to very easily style our web pages without having to do all the styling ourselves, right? So there's plenty of libraries out there that make it very, very easy to make a application and a web page look very, very professional. I'm going to use Bootstrap for the assignment all throughout the semester, right? But for your project, right, you're more than welcome to use other CSS libraries. If you want to purchase a very pretty CSS library, then go ahead. But that's for the project, right? For the assignment, we are all going to use the same Bootstrap CSS library. Okay. Then we'll up to this point, we've up to week 4, we have been talking about static content, right? Just brochures, right? That's as far as you can get with static content. Then we'll learn how to be able to program our web applications so that you folks can start interacting and dynamically generating content. The application reacts to our actions, right? As you interact with it, the application can react, right? And depending on our actions. So we'll introduce JavaScript. And so JavaScript is the backbone, the underlying mechanism by which we can generate dynamic content on the browser, and just like we did with CSS, right? We learn the kind of basics, and then we introduce a library that builds on top of CSS to make things more professional and much easier to use. Same thing with JavaScript. We'll first introduce the basics of JavaScript, and then we will introduce a library that sits on top of JavaScript. Well, it is a JavaScript library, but adds many really modern ideas such as components and objects and things that allow you to build and much more complex applications, allow you to break up large applications into smaller components that can be reused. They're self-contained and modular and whatnot. And we'll talk about best practices and how is it that you can make them reusable, right? That you can define your own reusable components. So we'll do that. Let's see, assignment, blah, 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 our ES6 and things like that, React hooks. Yep, we're going to be cover that, of course, definitely. Yeah, yeah. The whole course is ES6. We will briefly dabble on ES5 real quick, just to know what we're losing, if anything. No, we're not losing anything. But anyway, how it used to be, and a before and after, right? But definitely we'll stick to ES6 mostly for the entire semester. We will. Can we use TypeScript? Yes, if you want to use TypeScript, that's fine. I will not be covering TypeScript in the course, but definitely if you want to use strongly typed JavaScript, definitely you can go that way. We will then on week 7 we will have our first exam. That should be on Thursday, 10/21, right? We'll have first exam. It will typically be take up the entire lecture. Notice that kind of been skipping. There will be a couple of quizzes before exam number 1. There'll be quiz 1, 2, and 3, and usually it will be about the content that we just covered in the last couple of weeks. So the Q1 will only be HTML, Q2 mostly CSS, Q3 JavaScript and whatnot. Yes. All right. So when we come back after the first exam, we will be covering how is it that we can maintain state in an application, right? Up to this point, we will have been using the default state management mechanism that comes out of the box with React.js. And we'll point out all the not deficiencies, but limitations and complications that the default out of the box state management implies, right? So so we'll introduce another mechanism that allows us to maintain application level state, right? And for that, we'll be talking about Redux, all right? And Redux is it's a very popular state management library that it's very popular in the industry. It has a very steep learning curve, right? And so hopefully by the time we get there, you'll feel confident enough with JavaScript and whatnot that we'll do tons and tons of trivial, simple examples for you to understand the concept. But yeah, just be warned, Redux has a very steep learning curve, and definitely it'll need us to repeat and go over it quite a bit. We will up to this point we will have been building dynamic applications, but that are only running inside of the browser, right? They're not going out to fetch any data, and any dynamic any dynamic content that you might be rendering. There's no way for the application to remember anything, right? For the application to be able to remember states between requests, right? We'll need to introduce a server, right? So on week 9, we'll introduce Node.js as our mechanism for implementing the client server architecture, right? Up to this point, we've only been working with the client. We'll implement our first server here that will allow us to send RESTful oh, I did have it. To send RESTful messages across the wire, and then the server either storing it in its own state, or like we will do in the following week, right? We will be storing that permanently in a database, right? For the database, we're going to be using Mongo, a non-relational database, and we'll be using the Mongoose library. So Mongoose library as the library that allows Node.js to talk to the Mongo relational database. I mean, non-relational database. All right, so the week 11 is where we will be start talking about the project. Well, actually, no, we'll be talking about the project all throughout the semester, right? Even early next week, I'll talk about the requirements of the project. You should be thinking about the project right away, right? Even doing some preliminary prototypes and maybe some designs on what is it that you want to build, and discussing it with your colleagues. What is it that you're planning on doing? Setting up the environment where you're going to be building this, the repositories, and so doing some wireframes. So by the time where you get to 11/16, you should be able to hit the ground running, and then dedicate the next 3 weeks at building this, right? I would encourage you to get started as soon as possible. right? So set up teams right away and start coming up with some design ideas, some wireframes on what you want the pages to be. And as soon as you learn about HTML, or maybe you do already know HTML, right? You start building some simple prototypes of what you want the pages to look like. Okay, so I would get that going right away and not leave it till the end. Although I know most of you will procrastinate towards the end. But yeah, I suggest get started right away. Anyway, we are collaborating with some folks in the. We're going to have a guest speaker that's going to come the week before Thanksgiving, right? And they're going to give a talk on ethics on how is it that you should build applications that are ethical. Oftentimes when we're building these kinds of applications, we have technologies to be able to gather information about our customers, our users, and store them permanently in databases, right? And so we have to be mindful on what information we are capturing, and let them know how we intend to use that information, right? And so there's some ethical and some unethical things that folks do with that information. So yeah, so we'll have a guest speaker come and talk to us about how is it that we should build applications and let our users know about what we're doing with their information. We'll break for Thanksgiving. When we come back from Thanksgiving, the next couple week or so, I guess 2 weeks, we'll be focused mostly on completing the project. Okay, this is a little bit of a buffer time that if we do need more time for some of the other material, right? If we do slip on some of these time on some of these topics, we do have a little buffer in there. We were asked to make sure that we do have buffers in all our courses for any eventuality. Hopefully we'll make it to Thanksgiving without a lockdown. But we were asked to be ready to go remote at any moment's notice. Hopefully that won't happen, and if it does happen, it should only have minor disruption on our course. Our course is already online, so hopefully we should be able to coast without any incidents. Anyway, the project is due on the 14th, and then our last exam number 2 is the last day of classes, right? Exam 2 is the very last day of classes. I believe the 18th is the official day, right? But I think that's like a Saturday or something. So anyway, so the 16th will be the last time we see each other, and well, hopefully I'll see you more after that, and please stay in touch. Hope that one of you becomes the next Elon Musk, and I'll come work for you or something. Okay. Yeah. So last day of class, we'll do our exam. Evaluations, we have about 10 assignments, which is worth 40%. There will be about 7 quizzes worth 10%. The project is worth 30%. And then each one of the exams is worth 10% each. Okay. All right, let's see. Can you all see me?
Yes.
Okay.
Yes.
Yeah, my Zoom is looking weird. It's like not refreshing. Huh. But everybody can still hear me, right? Everybody can see the screen?
Yep.
I think it's
Yeah.
frozen.
All right.
But it keeps freezing though sometimes.
Okay.
There was just a little bit of lag, but now it's fine.
All right, let me check the speed test. All right, so not too bad. All right. Okay, so late submission. So yeah, so the late submission is very simple. Basically, if basically, the assignments are due, whatever date it says. And if you need a couple more hours, that's fine. You can submit it a couple hours late. You will lose 1 point for every hour that you are late. Okay, so there's no need to ask me, can I submit it, 5 hours later? Go ahead, right? We'll just see the date that it was, the time that it was submitted, right? And whatever hours that you went over, we will remove a point off of that. All right, wait a minute. All right, so the assignments, we are asking that all the assignments are private. Okay, that the code is just to make sure, because everybody's working on the same thing, right? Everybody, for the assignments, we're all building the same project. We want to make sure, we want to reduce the opportunities for folks to copy from each other and whatnot, right? It's fine that you can use all the material that I give you. You can copy from my repository, and so most everybody is going to start from the same place, right? Whatever material that I provided, right? That's totally fine. You can use that verbatim, but definitely not copy from anyone else. So please make the repositories private. You probably need to invite myself and the TA. The TAs are going to share with you a spreadsheet that shows you who your TA is, who's going to be grading you, and you'll need to invite them as a collaborator, right, so that they can see your code on GitHub, right? All materials, all assignments will be just submissions on GitHub, right? So you won't need to upload any source code or any zip file, anything like that to Canvas or anything like that. On Canvas, the only thing you need to submit on Canvas pretty much is always going to be the same thing: a URL to your Git repository, a URL to wherever your application is being hosted remotely. In this case, it'll be some URL on Netlify or AWS or wherever you're hosting your server. And towards the end of for the project, we'll also ask you to submit a link to the repository for your project and the server wherever you're hosting that your application. But yeah, so it's always the same thing, right? And TAs are going to visit your repository. They're going to clone it down, right, so that they can run it locally on their machines, and then they can grade you based on some rubric and give you a grade for that. Academic integrity. Yeah, so I can't stress enough that please, all the work that you do needs to be yours. Please abstain from looking at other folks' code. It's fine that you use my material verbatim, that's fine, but anybody else's, please abstain from collaborating in the assignments. Collaborating for the project, that's expected, right? You're expected to collaborate in the projects in your team, right? In your team of 2 or 3 or 4, right? You're all going to get the same grade, right? Irrespective of who does more work than anybody else, right? So make sure that amongst yourself, right, that you understand that you're going to divvy up the work, and everybody's going to try and do their part. Okay, but for the assignments, right, it's everything has to be your code. The TAs are very good at spotting source code that they might have seen elsewhere, that as they're grading somebody else, right, they're going to run a couple of tools, and just to compare source code, right, and see if obviously everybody's going to have the same source code that I might provide to you, and that's totally fine. But if it's anything that I have not provided to you that needs to be yours, and it needs to be right, not copy from anybody else. So yeah, so definitely abstain from plagiarism or anything like that. I am required to notify Oscar if I do suspect of any dishonest activity. So please, that's always a drama. Folks, and just puts me in a very awkward position, and just please spare me that, okay? All right. any questions? Right, if you're a student with disabilities, please contact me privately, and we can make whatever arrangements you might need. And I believe I have received a couple, but just let me know, remind me. You know, don't hesitate to reach out to me, and we will accommodate whatever needs you might have. All right, this chat died. Let me see if what is going on. Hi, can you still hear me?
Yes.
Yep.
Oh my goodness, what is going on? The chat window, can you see? Can you see? Oh, there it is. Now it's rendered. Okay. Okay, let's see. Zoom sharing, blah, 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 is lagging. Okay, do we need to make GitHub account with our Northeastern? No. All right, so do not use the GitHub that you might already have with the Curry or from your department or anything like that. Don't use the GitHub from the college. Instead, we're going to be using github.com, right? GitHub.com is a little allows you to share code and invite folks if it's private, and if you're going to use it later on for the industry, right? It's better to just have something that it's not tied to any particular organization and it's just yours personal. So yeah, use your GitHub account, github.com account. Are we going to go over any rendering optimization or any sort of performance optimization? No, I mean, we'll talk about it, but no, we're not going to be using any particular optimization. Blah, 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 blah. Okay. Why is Zoom being? Do you see how it's lagging? How it's not rendering? My chat window? Oh, you can't see my chat window?
No.
No.
Well, I can't see it either. Yeah, Zoom is being weird. So I might not be able to read your chats. Sorry about that. So feel free to just interrupt me and we can answer any questions. Okay. All right.
Oh, sorry, I do have a quick question.
Yes, go ahead.
Yeah, so are we expected to, like, let's say, come up with like our own project? So for example, like what this project is about, are we expected to like come up with our own, or are you going to give us like a specific topic?
Right. Yeah. So we're going to be working in two different projects, right? In the assignments, A1, A2, A3, the one we're starting today, and for the next 10 assignments, right, or 10 weeks, we're going to be working, everybody is going to be working on the same project. Well, I mean, each one of us will have our own version of a project. We're all going to be building the same thing. We're all going to be building a clone of Twitter. Okay. So student 1 will build their own version of Twitter, and student 2 will build their own version of Twitter, using the assignments as a guide, right? Assignment 1, assignment 2, assignment 3. Each week, we'll say, okay, well, now let's build this for Twitter. And then they'll build this for Twitter, blah, 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 right? And so those are the 10 assignments. Then towards the end of the semester, you're expected to come up with your own project idea, right? And you can go crazy. You can do whatever you want, right? There are some requirements that are you need to stick to. Like, for instance, you need to have a certain number of pages, right? You have to have a database. You have to have a server. There has to be communication between the client and the server. So there are some requirements, right? And you have to have certain complexity, right? You have to have at least 2 domain objects, at least 2 users, right? That are doing different things, right? So yeah, there's some requirements, and we'll go over what the final project requirements are. But yeah, it's something that you come up with on your own with your team members. Does that make sense?
Yeah, sure. Thank you. And how many people are going to be like working the same team?
Yeah, it could be either between 1 and 4.
Okay, got it. Thank you so much.
Okay. All right, excellent. So yeah, these are the office hours for the TAs, and these are the code repository. This is my code repository, github.com Janunzi. And this is where I'm going to be sharing source code with you each week. Any work that that we do together here in class, right? I'll commit, right? I'll push it, and then it'll be available here. I'll provide a link to it so that you can retrieve that source code. You are free to use any source code that I share with you, right? But not anybody else's. And it's fine that you might find something on Stack Overflow that does something that you don't want to have to rebuild it from scratch. It's fine if you copy a couple of lines of code from here and there. Just make sure that you're honest about it, and say, well, this is not my source code, and tell us where you got it from. Okay, and that's fine, right? If it doesn't pertain exactly to what the assignment asks you to do, it's fine for you to use resources from elsewhere. Just make sure that you don't submit it as if it were yours. Okay, just be honest about it. And when in doubt, just ask. Right, whenever there's doubt, just make sure to run by us, and we'll be cool about it. All right. Okay. Let's see. All right, I'll just go very briefly on a little bit of what is web development, and a little bit about the history of the web in general, and then we can jump on the assignment. Okay. All right. So present. Let's see. Web development.
We can only
Yes.
see the Zoom. I don't think the presentation's being rendered.
You don't see the. Okay. What about?
I
what
don't
about
see it
now?
either.
Yeah, just the web browser.
You can see your mouse moving though, so it's not frozen.
Okay.
I think you're only sharing the Chrome window, probably. You have to share the complete screen.
Oh, is that it? Let me see. Share.
Now we can see
Yeah,
the dots.
now we can see
Yeah, now
it.
it's visible. Yeah.
Oh, you know what? Now, can you see now it says web development?
Yep.
Yeah,
it's
visible.
Okay, and now can you see the presentation?
Yeah.
Okay.
Yeah.
All right, web development. Okay, so what is the internet? So basically, the internet is just one huge global network, right? It started as a research project by DARPA in the 60s, trying to prepare for World War III, right? We had come out of the World War II, and folks were saying, well, how did we win World War II? And then folks said, well, we bombed the heck out of the Germans, right? And we just completely obliterated their mechanism of being able to move around and then communicate, right? And so folks were saying, well, how do we avoid being victims of the same thing? And how do we make sure that we don't fall into that same scenario, that folks are going to remove our ability to communicate? So they come up with, well, how can we make a tremendously redundant network that there is no single point of failure, that you could drop bombs that in a single point of place, right? And then just you can't talk to anybody. So how can we create these networks of networks, such that there's if you destroy one particular part of the country, you can still communicate using other redundant networks. Okay. So yeah, it was definitely a military project. It was opened up to academia in the 80s, and finally in the 90s. And folks were saying, well, why commercial? Who could possibly do anything with this, right? So nobody would have thought of what the internet would eventually be. And then the web is just one particular use of the
Excuse me,
internet.
we are viewing the first page of the slides, not the presenting mode.
Okay, so you're only seeing the first slide?
Yeah.
Right.
How about now?
No.
Still
the same.
What the heck is going on? How about now? Can you see the second one?
No.
No.
No, I think you're still only showing one window and not the whole screen. So we're still just looking at the presentation in like the Chrome
Yeah.
opening, not the presenter view.
I think what you can do is probably stop the screen sharing and start again.
Yeah, the thing is that Zoom is like I think Zoom kind of like crashed a while ago, and it's not re-rendering anything for me. So like for instance, the new share. So I'm gonna try and restart the meeting.
You're muted.
Oh, there we go. Can you hear me?
Yes.
Yep.
Yeah, Zoom quit on me, and then it just rebooted. All right, let's try this again. Share my screen. Screen 1, screen 2. All right, can you see my screen now? What is the web?
Yeah.
No.
It's the desktop.
Just showing your desktop.
Oh, the desktop. Okay. Share screen. Okay, how about now?
Yeah.
It's visible now.
What is the web?
Yeah, now it's the fourth slide.
Yeah.
It's the fourth.
Yeah.
Okay, good. Live transcript closed. Caption has been added. Who can see? Has been enabled. Okay, so it's recording what I say. Good. Yeah. So as I was saying, the World Wide Web is just one of the many different things that the internet can be used for. It turned out to be the most popular use of the internet, right? And it was basically a research project that Tim Berners-Lee in the late 80s, he wanted a mechanism for which he could easily share his research papers with his colleagues. Can you see the slide?
Yeah, presenting.
Yep.
Yes.
And so he said, oh, well, how can I, come up with an easy way that I can format my research papers, right, with the common, and he says, well, what are the things that I need to create in a document, in a research document? Well, I need to have tables, and I have to have headers and paragraphs and list different things. And so he came up with a language, the HTML language, the hypertext markup language, as a mechanism for formatting these research papers. And he says, well, also usually these research papers are, some of them are my machine, and some of them are in my colleague's machine over there, and somebody's are in another university in a different country, right? And having the internet be able to communicate and fetch all these documents across the network, he came up with the idea of linking them together, right? And creating hypertext, meaning text that is active, right? That if you touch it, it reacts to you, right? He also created the idea of having servers that we would be able to host these documents, and he created the protocol that these servers understood about, retrieving documents, and then as these documents came back, he also came up with the first browser, right, that could interpret this format and then display the document electronically, right? So on his own, he came up with the World Wide Web, right? And which once it was able be opened up to the rest of the academics, right, it just took off exponentially from there, and folks have been finding new and exciting different ways of how to use this technology. So browsers are software that can read HTML document and then render it for you on a window, whereas servers are the repositories of these documents, right? That browsers go and fetch from servers. Give me this HTML document, it gets downloaded, and then it's rendered for you. And then he also came up with a mechanism for being able to find anything on the internet, right? Where you can uniquely identify each one of these documents with what it's called a uniform resource locator. How can you find all these documents in such a huge network, right? So he came up with that as well, as based on a hierarchical structure, very much like directories, right? Within directories, starting off with the location of which machine on the net, right, has this particular document, right? And then from there on, you can navigate down to a particular folder where that document is on that machine. Very, very clever, just genius. So just a couple of milestones, right? In the 60s, DARPA comes up with the internet. There were tons of different standards, competing standards on what was the mechanism by which the data makes it from one machine to the other. Eventually, they decided on a particular TCP/IP mechanism for transmitting this information, these packets around the world. They came up with this idea, this overarching architecture on different machines on the network had different roles, right? Some machines were mostly holding the repositories of data and repositories of documents, whereas other machines were the ones who wanted those documents, right? And so these roles, even though they were both just pretty much computers, they were running different pieces of software. One was designed to go fetch data or request data from servers, and servers software was designed to receive a request, fetch the document that was being asked for, and then send it back, right? So so the client server architecture is still today is one of the main architectures by which most applications are built around. And they participate, clients and servers participate in a request response cycle, right? The client sends a request to the server fulfills that request, right, and sends a response back to the client. And most applications today are still following this very basic architecture. Then there was in the 80s, you had this revolution of personal computers, instead of having these big mainframes, server mainframes, and then people having these rinky-dinky, very, very dumb terminals. As the price of the chips and computers fell and became much more available to everybody, and Apple and IBM blah, went into this war on the personal computer. Folks now have these computers just sitting on their desks, right? And now instead of being a dumb terminal, right, now you could think of having much more powerful clients, right, where you didn't just have text, but yeah, you could have graphics, you could have images and maybe animations and things like that. And as the machines became more and more powerful, now we have 3D, super realistic 3D worlds where people are immersed and with AIs running and all sorts of really powerful games, right? So anyway, then in the 90s, you have the World Wide Web, built around this huge superstructure of client server personal computers talking to one another. And now the World Wide Web explodes on how is it that anybody can just create content and share this content with anybody. Folks now in the 2000s, folks were saying, well, instead of having these content be static, how can we make it dynamic? And how can we build a lot of the applications that we built for the personal computer, right, that we were distributing in diskettes, right, or CD-ROMs or whatnot. It says, oh, we could build these applications instead of distributing them in hard drives or in diskettes or CD-ROMs. This could actually live on the cloud, right? And then the distribution is instantaneous, right? Instead of having to update an application and send you a new disk or a new CD-ROM, the application is always up to date, right? The application just lives in one place in a central server. So we kind of went in circles, right? We went from in the 70s a big huge server and then lots of small little dumb terminals to a more distributed architecture where everybody had their own personal computers running their own personal application. And then we went kind of back to where we were in the 70s, right? Where now you have everything on the server again, right? And now the client is just the browser, right? So the browser became our overarching client, right? Our dumb terminal, which is not so dumb, right? The browser is pretty powerful today. And now today, right? In 2010s, we have the mobile computing, right? Where instead of having this desktop machines, now we're carrying supercomputers on our pockets, right? And where you can talk to it, you can send queries to servers, and these servers can run supercomputing servers where they thousands of machines can be used in milliseconds and come up with a very powerful response, right? What's next? Who knows, right? In the 2020s, maybe Elon will have Neuralink, and we'll be able to just plug in our phones to our heads, and then we don't even have the physical computing a phone in front of us, and we will all become cyborgs or something. I don't know what's coming up. You let me know. Along the way, there's a lot of technologies and a lot of pieces of software that were being developed. In the early 90s, folks were saying, well, how right along here in the 90s, right, when we were trying to make the World Wide Web, and we're kind of transitioning and seeing how do we create applications running on the web, right? We were looking at, we were experimenting on how is it that a client can send a request to a server, and then the server, right, instead of coming back with a static content, document, a text document, how could we maybe run something on the server, and instead of sending a static piece of text, right, maybe we could run some function, right, and then that function can calculate what that text goes back to the server. And so this was, this opened up a tremendous opportunity. Folks started coming up with tons of different ways of doing the same thing. One of the first that was very successful was PHP. And this was code that was running on the server, calculating this dynamic content. So the page, instead of being this static brochure with static images and static content, now was a computed content, right? So that, depending on what time of day you went to go to weather.com, depending on the time, you would get a different weather, right? So the weather was dynamic. If you went in the morning or the afternoon, you would get different updates depending on when you went. So that now the content was dynamic. And there were tons of technologies that really pushed this idea to very, very advanced ways of building applications. The first major breakthrough was Java's Enterprise Edition that took this idea of server-side computing to very, very powerful results. .NET was also playing that, Microsoft playing in that same space, but tons of server-side solutions, Ruby on Rails, Django, Node.js, Flask, Python. So all these are server-side solutions, of which we're going to be focusing on Node.js, right? So that's going to be the focus of this this course, right, for the server-side solution. Now, on the client side, also there were a lot of development. In the mid 90s, yes, we can run code on the server, right? But we can also run code on the client, right? Remember, we have two sides of the coin. We have the browser, right, running on our machine, making requests for a server that is way out there, right? And code can run on both sides. It can run on the server. We can have code that runs over there, and that server could be .NET, it could be Java, it could be Python, it could be whatever, right? Now on the client side, right, on my machine, on the browser, the only language that is supported up to now is just JavaScript, right? That's the only thing that browsers can execute locally. Although there were attempts of expanding the power of browsers, and Adobe saw an opportunity. Browsers have a mechanism by which they can you can request a piece of the screen, and then you can embed anything you want in there, right? And Adobe took that to the extreme, right? And they really went along with Adobe Flash, and that allowed you to create very powerful user interfaces, right, running on the browser. JavaScript was still in its infancy, and was being just used for really simple stuff and a lot of cat animations, some form validation, some really simple stuff, right? But Adobe really just poured a lot of effort into pushing Adobe Flash as a way of building very rich, very powerful client applications. Okay. In the meantime, JavaScript was also making strides at creating libraries that allowed you to build large applications. JavaScript is just a language, right? Just like Java is just a language, or C# is just a language, right? What the beauty of any particular language or community is, what are the libraries that a community comes up with, right? That make developing applications easier, right? If you're just going to build an application with just plain Java, that would be very, very hard to build anything, right? Or any language, C# or anything. Instead, you rely on libraries that the community has come up with, either open source libraries, or libraries that you buy, libraries that allow you to do 3D animation, or matrix multiplications, or whatever, right? And so a whatever language you choose, really what shines is what are all the libraries that are available within that particular community. So anyway, so JavaScript evolves over time, and as folks were trying to build more complex client-side applications as an alternative to Adobe, right? All these libraries started to pop up, right? So Dojo was one of the first ones. Then jQuery, Knockout. These were libraries that were making it easier and easier and easier to build, more and more complex applications, larger applications, right? And the first breakthrough was Google's Angular. Angular is a library that allows you to build component-based, reusable modular applications, which allow you to take a look at a large application and build it into, split it up into small little components. Each one can be tested independently. So it was the first real attempt at creating software engineering, implementing a lot of the best practices in software engineering. Alongside, you had Backbone, Ember, Sails, Meteor, and then in 2013 we have React.js, and this is the library that we're going to be focusing on. Vue is picking up steam quite a bit, which definitely that would be a great library to look at as well. Anyway, so this is a little bit of the architecture of the applications that we're going to be building, right? So on the client side, this is your browser. Although the client can be anything, right? The client is just one application that is meant to go out and request something, right? That's the client. The client that we're going to be working with mostly is just a browser, okay? But it could certainly be just a desktop application, or maybe a game that is running on your machine. That could be a client, right? And they could send out requests, and or notify their state, right? So if it's a game, right, and it's a multiplayer game, the game might notify the server that your player has moved over so many steps to the left, right? And it's notified to the server notifies everybody else, and then you get notified about everybody else's state, right? And then your game re-renders that state across everybody, right? And then the server is responsible for, right, receiving all these requests from different places, from different clients. It could be dozens of clients, could be hundreds of clients, right? And the server is responsible for receiving all these requests and making sense out of them, and then notifying everybody else what the state of the application is, right? Also, servers are responsible for interacting with all sorts of resources like images and documents and HTML and text and PDFs and whatnot, right? Or also interacting with databases, right, for permanent storage and whatnot. Okay. And so what in the internet, typically we think of this cloud of all these machines that are interconnected with one another through the internet, right? Typically or historically, up until up until maybe 10 years ago, before Angular really picked up, right? The architecture of designing or implementing dynamic applications was something like this, right? The user interacted with their browser, right? They with a page, either they clicked on something or they're navigated to a new document, and maybe they asked for today's weather, right? And the server received this request. It calculated the response, right? Saying, well, today at this time it's raining, right? And it's cloudy and whatnot. So it dynamically generated the HTML document that went back to the browser, and then the browser rendered it. Okay. So this is the old way. Well, not old. I mean, we still do this, but the more exciting, what today is happening, the modern way of implementing this is different, right? The architecture is slightly different. We still have client, browser server, client server, right? But instead, the set of steps is, the browser first goes to the server and asks for a kind of like a template, right, of what the content might be, right? And that template is empty. Well, not empty. I mean, it's got the layout and the more or less the architecture of the document that you're going to render. Plus, it downloads a code, right? Usually, JavaScript code that is going to run on the browser. Okay, and then the browser starts executing this code, this JavaScript, and finds out that it needs data because the browser has no database, no anything, right? Goes out to the server again and says, oh, I have the template of the weather, but tell me, what's the temperature today, right? Is it raining? Is it cloudy? And the server provides data, right? Only data. The browser uses this data to then dynamically execute the JavaScript and dynamically render the content on the browser, right? And this is the more common architecture of most of the modern applications that you see today. And if you're using Google Mail or Google Maps or Amazon, Facebook, Twitter's, all these applications are following this type of architecture, and this is what we're going to be focusing mostly this semester, right? Not to say that this architecture is not used of browser servers and the rendering content. This is still used as well, right? But more modern applications go this way. All right, I'm gonna leave this content for maybe next week. I do want to talk about the assignment, the first assignment, and discuss that before we go today. Any questions so far? All right. Okay, let me close that. All right, so let's take a look at the first assignment. I know folks are already got started on the assignment, but I do want to demonstrate. We'll go real quick. So the first assignment is on setting.
We are
Yes.
still seeing the slide.
Can't see a screen.
We're still on the presentation.
Oh, is that what's happening? Wait, let me stop sharing. Let me share again. I think it gets confused when I use my second monitor. That's probably what's going on. Uh-oh. I lost my Zoom screen. I can't find my share screen button. Where'd it go? Can you still see my screen?
No.
No.
No, sir.
No. All right, let me restart Zoom, okay? Let me restart the meeting. I'll be right back, okay? Just a second. Hold on. Don't go. Still there? Okay, everybody's still there.
Yeah.
Yeah.
Okay, let me start sharing. Try sharing again. Oh wow, it's still. Okay, can you see my the assignment?
I can only see a gray screen.
Yeah.
Gray screen.
Same.
Okay, let's stop sharing. Wow, this never happened to me. What's going on with Zoom? Well, let me quit again. Just a second. Okay, can you see my assignment?
Yep.
Yes.
Yeah.
Okay.
Yes.
All right, let's try this. All right, so let's see. So setting up the web development environments. All right. This is going to ask you to do a couple things that we're going to be using throughout the semester. It asks you to set up a use a particular development environment or integrated development environment. I'm suggesting IntelliJ, but certainly if you prefer to use code or something else, then feel free to do so. All right, I strongly suggest IntelliJ. Although I know some of the criticisms of IntelliJ, but certainly it's widely used in industry and it's pretty good. So I'm not going to walk through downloading IntelliJ. You can go to download it from here. You might need to create a student account using your northeastern.edu to get a free license. So go ahead and do that, right? Unless if you prefer to use code, that's fine as well. The thing about IntelliJ is that you're going to be able to put breakpoints everywhere, right? You're going to be able to step through, especially the server side code is very hard to debug, right? Unless you can step through it. So definitely you might want to consider that. For the server side, we're going to be using Node.js. I mean, there's tons of servers out there. There's Tomcat, Glassfish, Jetty, Nginx, and whatnot. for different languages such as Java, Python, .NET, Perl, blah blah blah. We're going to stick to Node.js, right? And I'm going to ask you to go there and download the very latest. Like, for instance, this is the recommended version, 14.17. You can download it. It's an MSI on Windows, and if it's on a Mac, it's a DMG, right? And just download it, double click it, and just follow the instructions for installing it. Okay. Right, which I already did, so I'm not going to do it again. If I did it right, you should be able to start a command line prompt, either on Windows I'm using Commander. You could use just plain old CMD or PowerShell. On Mac, you could use just the plain terminal app. Once in there, you should be able to run and execute the node command. Right, so node and ask what the version of node. There it is. It's there. 14.16. So I'm a little bit behind, but that's fine. 14.16 is plenty. Okay. Along with Node, you're also going to get several npm and npx executables. All right. And what these are package managers that allow you to download libraries that were built for Node. Right. We're going to be using lots of these libraries, right, for creating our servers. And it's got tons of tools and whatnot that we're going to be downloading for Node. The one in particular that we're going to be using, one tool that we're going to be using in particular is a tool from Facebook, right, that allows us to create a boilerplate React application, right? You run the tool and it builds a ready to go configured application where you can start implementing your React application, right? And this assignment just walks you through doing that, right? This is asking you to create a directory where you're going to be doing all your work. Let's see, there's a question on the chat. More like homebrew. Yeah, exactly, like homebrew or Java if you've used Maven, right? Or yeah, homebrew. There's tons of these packages for different languages, right? Yeah, so the assignment asks you to choose a directory where you're going to be doing all your work, and then create a kind of like a web dev directory in there where you're going to stick to it, right? So let me see. So I'm going to go users Jan NEU. What do I have there? So 2011. So I already created fall. I already created web dev. And there's nothing here in web dev. I have this temp directory. Okay, so in here, I'm going to create my React application, right? And I'm going to use a tool. If you just follow along, this is the command for creating a brand new React.js application that is already ready to go, right? So I copied it. I'm going to paste it here. Do enter. So this is npx. It's a command part of the Node installation, right? That allows you to execute packages that were written using Node. It downloads the executable, executes it locally in your machine, and this is was created by Facebook, right? And Facebook provides this for free, and then you tell it the name of the application that you want to build. Okay, what this is doing is that it's creating a directory with this name, right, called web-dev, web-dev, and it's downloading tons of libraries, right? A lot of JavaScript libraries and things that I compile for in my particular operating system, and it's creating a Node project, right? A Node project, as we'll see in a minute, has a particular file called the package.json file, right? And that's how you know that this is a Node package. That's similar to in other languages, like for instance, if this were a Java project, typically in a Java project, you find a POM file, pom.xml file, right? And that's how you know that that's a Java project, right? And in different languages, different infrastructures will have their own particular set of files that are specific to that type of project. For us, a node project has a package JSON. So the package JSON, as we'll see in a minute, right, lists all the libraries that your particular project depends on, right? So that, if you're going to deploy this, right, you need to make sure that you have all the dependencies so you can build it. There we go. It's done. If you go to ls LA, you'll notice that indeed it created this directory. That directory is the React project, right? So let's go in there. So let's go cd web dev. We'll do an ls. All right, so this is the content of the project. Notice that it has this package JSON, right? That's how we know that this is a node project. Now, node projects can be, can implement anything you want, right? It could be a desktop application if you want to build something, or it could be a mobile application that runs on your phone, or in this case, it's a node project that implements a web application, right? Something that can run on the web. Okay, and in particular, it's a web project, right, that is using a specific set of libraries, right? And that library, the overarching library that is being used for this web application is React.js. Okay. Anyway, we'll have plenty of time to talk about React.js and whatnot. The focus of this assignment is to just set up the environment, right? Run it, deploy it, so that we can, have it running on a remote server. All right. So notice that package JSON. We know this is a node project. Notice that it already has been configured as a Git repository. It's a local Git repository. All the history of what you change, all the files, is being kept here under Git. You get git ignore, like the assignment asks you to do, asks you to edit that file. We'll do that in a minute. Node modules is all the libraries that were downloaded for this project live under node_modules. The public is the root entry, right, of the server, right? So this is where the server, if you ask for any content, that's where the content of the server is going to live. In particular, the index file is in there, very important file. And then we're going to be spending most of our time under the source directory. In the source directory, we'll have all the components that make up your application. Okay, we'll talk about a little later that. Okay, so how do you run that? You run it using npm start, right, as the assignment should say. Yeah, npm start. We went into the directory and then npm start. npm start. This is going to kick off the server, the Node.js server, and it's going to run our web application in a brand new browser. Let's see. Yes, no, maybe. Oh, there it is. And there it is. Okay, magic. We have a running React web application. This is the default out of the box web application. Okay, so next, right, we want to deploy this on a remote server, right? So how do we do that? So the way we're going to do that is, as the assignment asks you to do, it asks you to set up a Git repository, source control, right? Now, if you're using a Mac, you already have Git installed on your machine, and you don't have to do much. If you have Windows, you will have to download a Git client, which I did already. I'm going to be using mostly just the command line, although you can use a UI client application. A really nice one is source tree. It's a nice UI for using Git. Definitely suggest using that. I'm going to be using just the command line. So before what we're going to do is that we're going to copy our source code into a remote source code repository in GitHub. Okay, let's see. There's a question on the chat. I've also had a Git Kraken recommended. Yeah, definitely. Right. There's tons of them. There's tons of Git repository, Git clients, but definitely go ahead. Right. So we're going to push our local source code. Let me stop this for a second. Right. Our source code is this here, right here, right? But we don't want to push everything. We don't want to deploy everything. Let's say something on the chat. Sorry, didn't mean to. Okay, that's fine. Yeah, please interrupt. That's fine. Yeah. So our source code here is what we want to share and when we want to push and deploy our remote server. But we don't want to share everything. For instance, all this in node modules, that's mostly libraries, right? Libraries that were, they're very well-known libraries, right? They were downloaded from a very well-known repository. There's no need to copy this over and over, right? So for instance, this is one of the files that we would ignore, right? We don't want to push this and copy these libraries over and over, right? So also, we're going to be using our IDE, IntelliJ, and IntelliJ, for its own purposes, it keeps track, it creates its own files, right? And none of those files also, we don't want to send them over to our source controller, right? Because that's specific to me. I might be using, somebody might be using code, and they don't care. I mean, they don't want to see any .ide or anything that has to do with IntelliJ in the source control, right? It makes no sense, right? So yeah, so we don't want to share any of that content. So let me show you, right? If I open it up here, let me close this. Let me close this project and let me open this. Open and let me navigate to the project we just created. There it is. Let me open that. So there's IntelliJ. And as you see, this is the same content that I see here, right? The same content. So if I open up ignore, git ignore, it has all these files that we don't want to send to our source control. There it is. So node modules is this one. We don't want to share that. It's just libraries. We don't want to do that. Compile libraries. Just like if you compile, .object files or .class files, right? In other languages, you don't want to put that in source control, right? Same thing with node modules. So notice that here we don't have .ide, see it, but we have it here. And the reason we have it here is because I just opened it with IntelliJ, right? If I do an ls again, notice that we do now have idea, right? And that folder was created by IntelliJ. We don't want to share that. We don't want to put that in source control. So I'm going to edit my git ignore and add idea. Okay, I'm done. And notice if I do a git status now, git status tells me that I have modified a file and that I want to make sure that I want to keep track of the changes that I make to all my source. So I'll commit this, git add, and then git commit ignored idea. Okay. All right, we're done. We're committed. All right. Let's now push it to a remote repository. To do that, I'm going to go to GitHub, and we're going to create a brand new repository. And we'll say web dev. I'm going to keep the same name everywhere so that I can keep it straight in my head of what I'm calling it locally on my machine. What I'm going to push it to my remote repository so I know that these guys are related. So I'm going to say public. I'll keep it public because I'm going to share with everybody. You're going to create it private, okay? Right, and then you're going to have to invite the TAs, right? So I'm going to say public. I'll say go ahead, build it. So it created it. Right now, the source repository is empty. There's nothing in it. The source is in my local repository, in my local machine. I'm going to copy the source code that is in my machine. I'm going to push it to the remote repository. So to do that, I already did git init. I already added my, I already have all this, right? I already have all my content. I only have to do this. To the remote, I'm going to add it. I could do it in my command, right? Or I can do it in my, if you see this terminal here, see that terminal, right? That's just, this is almost like it's a command line, right? So I can do it either here, right? Or I can do it from my command line. Notice that I'm in the same directory. This is the root of the project, web dev, same thing. I'm in the same directory here, right? So I can do it here at the command or here. So I'm gonna, oops, that's not what I want. I'm gonna copy this, paste it. What this is doing, it's saying that hey, the source that you have locally on my little local Git repository, I want to associate it to a remote repository that lives in this server, right? And for this user, and that's the name of the remote repository. Okay, and I'm adding it as the default repository that if I push, it will copy all the content to that remote repository. I say that. Okay, now I have a remote. I can say remote. Notice that it lists that there's an origin. I just created it. I can see verbose. I can see that that's what it's pointing to, right? Whenever it pushes or you pull, right, the content is going to be maintained in that remote repository. So, okay, now we're ready to push. Say git push, and that's the command that's going to push all the content. So it's copying all my source and it's copying remotely. If I come here and I refresh, notice that all my source code now lives in that remote repository. There it is. So notice that it's the same exact content, right? If I do ls, right? So I have my public, my source. There it is, my public, my source. Git ignore, same thing. Notice that I don't have node modules. There it is, node modules not there. I don't have .idea either, right? Because we told it to ignore it. You know, I don't want that, right, in there. All right, perfect. We have that. Okay, so now we want to be able to host this content in a remote server, right? And for that, you can use AWS. Some students want to use AWS. That's fine. If you want to play around with that, definitely I encourage you to explore that. But there's some easier solutions for this, right? Netlify, just provides a very, very easy, one just pushes the button and just deploys the application very, very quickly. So I've already created an account here. I encourage you to do the same. I'm going to just log in. You can log in with an email or with your GitHub credentials as well. You can connect your GitHub repository to Netlify, and if you want a brand new application, you could just say new site from Git, and it says, okay, well, it already knows my GitHub account, and it knows how to log into my GitHub repository, and it's saying it's authorized and making sure that it can log in, and then you can search for the repository that you want to deploy, and you can say, well, in this case, it's WebDev. I just created it 2 seconds ago, right? It's finding it, and let's see if it finds it. There it is. It's this one, right? It's Genuinely WebDev. Let's click on that. You can select the branch that you want to deploy, and you can say just deploy the site. Now, what this is going to do is that it's cloning down the repository, right, from GitHub, and it's copying it into their own servers, right? And then it's running several scripts. It's downloading all the libraries, right? It's setting up the directory structure. It's compiling them. It's concatenating JavaScript, concatenating CSS, right? Putting it all into a single HTML document, right? And just compressing everything, to improve the performance of the download of the content, right? And basically, it's deploying it. So it also comes up with this bogus name for my application, right? I called it web.dash. Instead, it comes up with some random name for my application. It's a kind Bartik something or other, right? You can upgrade and pay for a fee. You can choose a domain of your own, right? If you want to call it, WebDev Fall 2021, right? You have to pay for that, right? You can buy a domain and then you can point it to this. All right, so it's done. It says your site is deployed. Oops. And so notice that it provides a link. You click it, and boom, there it is, right? So locally, we have this running locally, and we have it running remotely, right? Where's our remote? Where was it? Oh, I think I stopped it, right? Let me go back to my commander. I can say npm start again. npm start. Yeah, so this is starting the server locally. There it is. So this is running remotely on my remote server, and this is running locally on my local server, and they look identical, right? Notice that they're identical. And that's the idea. What we're going to be doing throughout the semester is that we're doing all development locally, right? Testing it, making sure that it works. And when we're happy, we're going to push it to Git repository, and then it will automatically redeploy here, because our Netlify is listening for changes in the Git repository. If anything changes, any file changes, it will automatically redeploy. Okay. Awesome. And that is the first assignment, right? For the first assignment, we ask you to give us this URL right there. You copy that URL. Also copy the repository, that URL, right, for your Git repository, and those two URLs, submit them as your for this assignment, right, in Canvas. Okay. All right, some questions in chat. How do you feel about using GitHub pages versus? Yeah. So yeah, the problem is that we're gonna need to run server code, and we need to run RESTful queries. If you can deploy just the static content to GitHub, then that's fine, right? And yes, you'll have to compile it down to the index files and the JavaScript and the CSS that it needs, and then you can deploy it as a GitHub, and that would be fine. That would be fine. Will you be able to access the GitHub link if our repo is private? Yeah, if you invite me and you invite the TA, then yes, we will be able to see the private repository. Yep. Let's see, what else? So we're a little bit over time, but that's fine. In a normal lecture, this would be when the office hours would start, right? So I would open it up for questions. You know, if you have questions about an assignment, you need help, we can work on that as well. Or if you have some general questions, this would be the time. Let's see.
Professor, I have one question. Can I ask?
Yes, of course.
Okay, so my question is why we do deploy to a remote server, like why we create an account and go to the
Yes.
remote thing.
Yeah. So the intent of you know, when you're creating an application, right? If you go to Wikipedia, right? Evangelion, I was looking. So this is running on a remote server, right? If instead I have this running on my local machine, nobody would be able to see this, right? It's as if I would be running Wikipedia on my local machine, and nobody would be able to see Wikipedia, because if I shut off my machine, right, then it stops running. So we want to deploy our application on a machine that will always be running and will be on all the time, and anybody who wants to come and read Wikipedia, they would be able to see it, right? And the servers are also much beefier machines that would be able to respond to thousands of requests, right? As opposed to my little rinky-dinky machine over here, you know, could handle maybe a couple dozen. And the way we develop is we first develop on our machine, local machine. We run it locally on our machine. Once we're happy, right, we want to share with the rest of the world, right? We then upload it to the remote server where it's running, and then thousands of folks can come and visit the remote server. That make sense?
Yes. Thank you, Professor. I
Sure.
have one more question. For 2 exams, midterm and final, what we are expect, like MCQs based or something else?
Secure what? I'm sorry.
MCQs. It will be MCQs based, our exam.
MCQs. I'm sorry. What does that mean? I'm sorry.
Will there be multiple choice questions or subjective questions?
Oh, yes. Mostly will be lots of most of them will be multiple choice, fill in the blanks, lots of fill in the blanks, lots of puzzles, where I might give you a snippet of code, and I might ask you, what does this code do? right? That if you click on this button, what happens? If you click on that other button 3 times, right? Then what happens? What if you click on A first, then B, and then A again, right? You tell me what's the output. And usually it will, the only way that you would get it right is that if you understand, you know, how the data flows and how functions get called, and you know, there's also going to be a lot of questions about whether something is syntactically correct and how would you fix it, and for you to implement certain things. But again, things that you could do remotely on your machine, you know, taking the exam or the quiz, right? There's not going to be any like open-ended written question. You won't have to like code and write code for the exam.
And how about the time frame?
Usually exams take up the entire, you know, about, typically is designed for 2 hours, but you have all 3 hours to complete it. TAs are going to be sharing a link, I believe, on Piazza. I think they did already. I think TA shared a link. Let's see, pin the session about lecture dates applying. Spreadsheet for students to find their TAs. So if you go here, presumably each TA has listed the students that they are responsible for. And some TAs haven't. Yeah, so the TAs are taking on, I think it's going to be like about 20 to 25 students per TA. Something like that. All right, anything else?
Professor, where's that Excel sheet? We could not find it on Piazza.
Ooh, it says private. Let's wait. I'll wait until the TAs decide. Wait, hi, professor and folks. This is a spreadsheet for students to find their, I think they meant for this not to be private. Please fill this out so that we can. Okay, well, all right. It's not ready to be shared because the TAs have not yet decided which students. There are a couple of TAs that are still deciding. So yeah, the TAs will make this public at some point.
And the get usernames will be in that same Excel sheet?
Yes.
All right.
Yep. Yeah. Well, actually, no. It should be available. Here, if you go to modules, the Git repositories are going to be listed here. So, for instance, I'm Janunzi. Yuan's is Yuan
We are
Silu.
viewing your Git page.
We can see your Git page only.
You can't see these links?
No.
No.
If I click on them, they go here. Huh. Oh, maybe they haven't published them. Okay, let me
I
see.
think we are seeing a separate window of yours.
They're still saying your Git repo.
Wait a minute. Oh no, that's made available. You see my repository? You don't see everybody else's repository? Anyway, it will be available in the code repositories link module. All the TAs are going to be listed.
Yeah. Currently, there are 3, yours and 2 others.
Oh, okay. All right, then probably they haven't made it available just yet, but they will be made available. You don't need them just yet.
All right, thank you.
Okay. All right, anything else?
I have a question, Professor.
Sure.
Are exams open book or closed book?
So the typically what I have students do is they can write whatever they want in a particular document, and they would have access only to that part, right? But they can write anything they want, whatever they can fit into sheets of paper, and and that's up to you, whatever you want to put in there.
Okay, so we're going to do the exam online, not
Yes,
in class, not in
yeah.
person.
Right, and online synchronously. So everybody at the same time that particular Thursday.
Okay, thank you. Someone is asking a question in the chat box.
What's the DDL for quiz if we can't take it in class? Yeah, if right, if there are edge cases that I know some folks are traveling, or if you have to take it earlier, right? We'll deal with those, you know, one-on-ones, one-offs independently. So just make sure to reach out to me, and we'll try to accommodate you.
Hello, Professor. I have a question.
Uh-huh.
Are we also expected to write unit test cases for our React code?
No. Yeah, no, we're not gonna cover testing, unfortunately.
Thank you.
Anything else?
Thank you, Professor.
Thank you very much.
All right, everyone.
Thank you.
Thank you, Professor.
Hope you enjoyed it, and definitely see you next Tuesday then. All right, have a great weekend.
Thank you.
Thank
Bye-bye.
you. Bye-bye.
Thank you,
Bye-bye.
Professor.
You too.
Good night.
Thank you.
Have a
Good
good
night.
night.
You too.
Love
Take
you.
care.